Empirical and molecular formulas. You're probably listening to those words and saying, what the heck is that? Well, it's really not that bad. It's the simpler molar ratio for the elements in a substance if you're talking about the empirical formula, and it's the actual molar ratio for elements in a substance if you're talking about the molecular formula. I'm pretty sure that that is no help at all. How about an example? Benzene, a carcinogen, which used to be a common solvent, which I used to use, is C6H6. Can you see that there's an equal number of carbons to hydrogens, 6 each? The empirical formula would be called C1H1, since that's the ratio, 1 to 1. It's not until you know more information that you have to realize, oh, there's 6 of each. So first you typically get an empirical formula, and then if you know some more information, you get the molecular formula. Go through this problem and I think it'll become clear. If you assume 100 grams in a sample, you're good to go. The reason is because you get percents. The question is, what's the empirical and molecular formula for a substance that has 86% carbon and 14% hydrogen by mass with a molecular mass of 28 grams per mole? A lot of lingo, right? Let's try to do what the AP people want us to do and try to visualize this. You've got a substance in front of you, probably a white powder. Most of it is carbon, some of it is hydrogen. What the heck is it? Well, if it's 86% carbon and 14% hydrogen, maybe there's a lot more carbon atoms than hydrogen. But that's probably not true because carbon's a heavy atom and hydrogen is a light atom. So if what we need to do is actually, considering the fact that this is bigger, we need to find out how many atoms of each we have, and for that we use the mole. 12 grams of carbon is a mole, so we really only have 7.1 moles of carbon. Now if you wanted to multiply that by Avogadro's number, you could figure out exactly how many atoms you have, but that's the relative number of atoms. On the other hand, hydrogen is just 1 gram per mole, right? So we actually have 14 moles of hydrogen. A nice thing about these problems is that they typically give you cute little ratios, 1 to 2. Therefore, the empirical formula of this substance is 1 carbon for every 2 hydrogens, or CH2. That is our empirical formula. They gave us some more information, though. I mean, this could be CH2, it could be C2H4, it could be C3H6. The molecular mass is 28 grams per mole. All I would do is say, oh, it's twice as big as this. There must be twice as many as that. Therefore, it is 28 grams per mole is its empirical formula. Is there a substance that molecular formula. Is there a substance that actually matches that? There is, ethylene, C2H4. Note that in this nice little drawing here, every carbon has 4 bonds. Every hydrogen has 1 bond. Our next topic is percent yield.